In this topic, we'll look at the trends that led to the emergence of big data. It didn't happen overnight. In fact, the foundations were laid decades ago. So we'll have a look at why we now have to understand terms such as zettabyte and exabytes, when before we were only using terms like bytes and kilobytes. I'm going to show you an ad from 1980 that features a pocket computer. This pocket computer was hot stuff back in 1980, and one of the key features that it promised was that it contained and would retain programs and data even when turned off. It would have cost you $175 back then. These days, that would be equivalent to about $450, which would probably get you a pretty reasonable second-hand laptop computer. The reason I wanted to show you this ad is because for me, it symbolizes in my lifetime how quickly and how important computational power has been in the development of big data. In fact, in 1986, if we were to look at where most computational power resided, 40% of it actually sat not in computers, but in pocket calculators. 33% of existing computational power in 1980 was in computers, and the remainder were in servers and even games. As we can see, computational power has been a main driver and has shifted into all kinds of devices. And one of the reasons for this is something called Moore's Law. Gordon Moore was the co-founder of Intel Corporation, and in 1965, in a thesis which he wrote, he suggested that computational power, as identified as the number of integrated circuits that could fit on a computer chip, would double every 18 months for the foreseeable future. And in fact, that's exactly what's happened. Mr. Moore projected a future in which computational power would continue to grow and grow and grow. But actually, I'd ask you to have a look at this video from the Mythbusters, because I think that they can explain Moore's Law in a more interesting and fun way than I ever could.
As I understand it, Moore's Law dictates that the number of transistors on a chip will double roughly every 24 months.
Now, does that mean that the speed also doubles?
Theoretically.
God, if you double your speed even once, I'd have an easier time staying awake while you were talking.
Yeah. Well, let me give some examples as quickly as I can. In 1949, the ENIAC computer calculated pi to 2,037 digits in 70 hours. Now, the modern laptop can do the same thing in 3.5 seconds, 5 million times faster than this 1950. Or I can calculate it another way. In 1971, the world's first microprocessor ran at 108 kilohertz. That's each transistor switching at 108,000 times per second. Today's dual-core processors exceed speeds of 2.5 gigahertz, or 2.5 billion operations per second, accepting the hertz measurement as a function of the performance.
That seems like about twice as
But
fast.
the modern computer can do more work than the old, so it's not a straight comparison. My laptop has 6,000 times the number of transistors, so you have to divide that 1.2 millimeters by 6,000. Let me put it another way.
I was afraid of this. However, it does seem to confirm Moore's Law.
Now, another reason for the emergence of big data is actually the number of devices that are now connected to the internet and are creating data all the time, constantly. It's been estimated that there are already 1 billion devices which are generating data and processing that data and communicating it across the internet. Now, that's a tremendous number, and it goes far beyond the old familiar favorites that we know, such as our smartphone or computer. So where are these devices to be found? Well, most of them we never see. And as a matter of fact, they're called M2M devices, or machine-to-machine. They're never talking to human beings because that's not what their job is. So what are these M2M devices so busy doing in the generation of all this data? Some of them are vehicle tracking devices. Some of them are fire alarms. Some of them are humidity sensors or emission control devices. Just to use one example, every year 16 million new vehicles are put onto the road which have navigational controls which connect them to the internet. So these navigational data devices are embedded in cars that we might buy. There are also 36 million additional portable navigational devices which are retrofitted onto vehicles. So this number of devices is growing hugely across virtually all sectors, and they will continue to generate at some point even more data than we humans are. And with this explosion of both human and M2M data, it's becoming increasingly important to actually visualize what it looks like. As you can see in this graphic from an application from Akamai, we can see the incredible power of the streams of internet data which are happening constantly. And if we were to look at it from a different perspective, and this visualization gives us a sense of Facebook data, we can see the tidal power that data has around us on a regular basis. And it also helps us to be able to manipulate and use that data, because at a certain point it's just getting too big to even imagine. So this visualization is a tool we can use to help manage the understanding of big data. Another major trend in the emergence of big data is the cost it takes to produce data storage devices. Now, the earliest data storage devices back in the 1930s were actually huge magnetic drums, which were only capable of holding a few kilobytes. Now, obviously, material science and chemical science and different fields and disciplines have worked together to bring data storage to the state it's at today. But one of the big underlying changes has been the economic structure of data storage, because it's been an industry which has been transformed on an incredible basis since about 1980. Let's look at the costs of data storage and the way that they've fallen so dramatically since that time. In 1980, for example, a gigabyte would have cost you a cool $200,000 US. By 1985, you'd be paying $70,000 for that same gigabyte. But just 5 years after that, the price would have plunged to a mere $9,000. By 1995, that cost even would have dropped to $950. By the turn of the century, you'd be paying about $20 for a gigabyte. 5 years later, a mere 75 cents. And today, the cost of 1 gigabyte of storage hardly even registers. Cloud storage has reduced that cost to below a penny, or virtually for free. In summary, there are 3 reasons for the emergence of big data. 1, the increase in computational power as described and powered by Moore's law. The number of internet-enabled data-generating devices, such as M2M devices that we now see. And finally, the falling costs of data storage itself, which make data available to everybody for virtually no cost. So, as we see more data that resides in the clouds, is being used by individuals and in devices, how are we starting to get our hands around it and put it to work? That's a subject that we'll look at in our next topic.